Was the career fair today? Yeah, seen a lot of people wearing suits, so I thought so. How many of you went? Oh, how was it? Good. Okay. Was bad?
Yeah.
Really?
Yeah, I mean, there's probably a lot of good, but the ones that were actually looking for tech. So, there was a lot of like civil engineering stuff. Yeah, a lot of
A lot of mechanical, I think. Civil.
the one thing while I was kind of good, it was like they had two spots for it. Yeah.
I see. What about Harris? Was Harris there? Buckhead Moran? No?
No, they didn't.
Oh, that's very weird. Okay, so we're gonna start here in a minute. A few things before we start. We're gonna go over the assignment that was released, and then we will pick up our lecture. Okay, so assignment 4 was released this week. This is our kind of last week before spring break. So assignment 4 is relatively very easy, I think. It's coming from exactly our module week 5, which is access control. So everything that is required in the assignment you can find, I think, in the slides, and you can find also in the recording, right? So what you are supposed to do is that you're going to use your Kali Linux, and you are going to go through this document and make sure you implement every command, right? So this is regarding access control and permissions, and even I think it has some like groups permissions. So you are just to go through this and then make sure that you do follow um, all the commands. Okay, you're gonna submit screenshots of the commands and what they do as well, and then you can turn it in as a report. One thing to note here, and it might confuse you, is that, and I mentioned it here, is that the report automatically assumes that you have a file, the test file. So what you need to do is you need to create the test file. Okay, so before you start, create the file and then follow the commands. Should be very easy. And then this one is going to be due about 3 weeks from now. So next week, spring break, I don't want to assign anything in that week, spring break week. So you have about 3 weeks for you to turn in this assignment. So you have a lot of time. I recommend you start very soon on it so that you don't have issues when it comes to the deadline. And then we have this, and we can discuss this more on Thursday, but basically, this is just a cool demonstration into data breaches, right? And it's got like a cool interactive site that you will enter here on your browser. And then basically, you will kind of do all these filters, or you can say these steps, and then answer one question in the end. Very quick assignment, very easy, just to kind of uh, give you some insights or facts about data breaches. Okay, so that is to be due the same due date as assignment 4. So you have a lot of time to get those done. So those were released yesterday. So last lecture or last week we discussed malware, and we have about a few slides to finish malware. Um, in the last slide we talked about, or the last lecture we talked about what malware is, the types of malware, how to kind of properly do the attack flow or kind of follow these steps to kind of have a successful attack, or trying to think as and kind of the brains of the adversary here is how they work. We did Nmap scanning. We did service detection as well, and then we did exploiting a little bit with a backdoor attack. And today we're going to finish that remainder, and then we're going to do a simple attack before we move to chapter 7, which is about denial of service attacks. Okay, so this is where we're going to pick up. Obviously, this is talking about worm countermeasures, how to kind of mitigate worm attacks. And we know that worms, if they can be exploited, they will obviously propagate to also other machines, right? So we need some way to detect them and make sure that they don't raise kind of or kind of like to minimize the risk or the vulnerability of these kind of worms. And there's some techniques. There's signature-based scan technique that detects like patterns. That's kind of like any kind of detection system to be used. Okay, and then we have filter-based containment. So we block specific traffic or vulnerabilities, and this is going to be very crucial when we discuss chapter 7. Payload classification containment. So we can try to identify malicious code within the network traffic. We can detect some abnormal behavior, maybe in the system, or scanning behavior. There's scanning behaviors that can detect abnormal kind of traffic. And then we can do rate limiting. So we limit the number of connections of attempts and kind of halting. So we stop hosts that show aggressive scanning behavior. When we discuss this with Nmap, when we do minus T5 or T4, and we're also going to see this with chapter 7, is that we can do aggressive scans or aggressive kind of denial of service attack. So we can also limit that or stop it in a way. So we have payload, stealthing, backdoor, and this is kind of called as a trapdoor. And we implemented this attack in the last lecture. Okay, that is going to be basically a hidden entry in a program that the attacker can use to bypass normal authentication. It's a vulnerability in a system that you can bypass without any type of authentication. Okay, so it is a very high, or you can say a critical level rated kind of vulnerability, and it will provide obviously unauthorized access to a system or application. Okay, so sometimes what tends to happen is the developers would leave these or kind of use it as to lure attackers to kind of maintain their system or kind of advance their system to leave that attack to see what would happen to the system, obviously in a sandbox area or something that is very similar. Okay, so if the attacker can kind of discover, they can also try to maintain persistent access, like using some stealth malware technique to kind of hide their type of attack. Okay, so controlling the backdoors in application is going to be very difficult because they may be in the embedded language or the embedded program logic. So we did this in the last. I'm going to launch my virtual machines because I will need them, whether it's for this or the other chapter. But last lecture, we did Nmap scanning, and then we identified a target system, and we found there's a vulnerability, the file transfer protocol in port 21. Then what we have done is that we wanted to exploit this vulnerability. Okay. So we used the Metaexploitable framework, and we launched MSF console. We found some vulnerabilities, obviously, and we want to test those vulnerabilities if they work. So it contains a lot of, like, you can say, kits or kind of attack modules or techniques, and it would be used by attackers or professionals to target these known vulnerabilities. So let me just demonstrate this really quick again. I'm gonna open my command prompt here, and So the first thing that we have done, yep, that's the command there. I'm gonna run it very quick. So we know that this is the first kind of step we find these vulnerabilities and we know this one exists. The next thing that we would do is try to do some exploits. So we launch MSF console. Okay, it'll take a minute to launch. And then we will search for this vulnerability and try to exploit it. So our vulnerability is going to be the VSFT PD. Yep. So that is what we're going to search for. So we're going to search for that. And we know there's a backdoor vulnerability that do exist here. It's ranked as kind of excellent, I think, as in terms of MSF console to launch this kind of attack. So we found the vulnerabilities. We need to set kind of the target that we want to or the IP address or the destination of the target that we want to implement or exploit the malware with, or this type of attack or vulnerability. And then we can launch the attack that we have. Okay, so we discovered it through scanning. Now we want to use this specific exploit that is here. Okay, so we are going to do use and then exploit. And then Unix. And then it will be FTP underscore 234 at door. Okay. So we're using that. The next thing that we do is we set the target, and that is going to be our meta-exploitable IP address. So that is going to be set our host, and then yeah, we put in our IP. Okay, and then we can just do run here. Okay, so we found the shell and we have the backdoor service that has been spawned. And when you see a session one that has been opened, and if we can verify it to see if we have gained access, is we just type in who am I, and then we have root access of meta-exploitable. So that is the backdoor attack that we demonstrated in the last slides, in the last lecture. We have another one that we want to do is another kind of vulnerability, and that was called Samba. Have anyone heard of that one before? Okay, so this is, I think, a vulnerability that has arisen in 2007. It's called username map script. Okay, and it's kind of like a file and sharing service that is used in many Linux systems, and it supports like Windows protocols. Okay, and this kind of vulnerability would kind of allow, bless you, it would allow attackers to execute commands remotely and through the username and the map script feature. Okay, so attackers can send some crafted requests that can cause the server to execute some commands, right? So the vulnerability would allow like unauthenticated kind of remote commands and systems like meta-exploitable. We can use that to kind of exploit this flaw to gain root level access, kind of similar to what we have done in the previous kind of slide. So this is kind of, we discussed this in the other courses. If you search the NVD, the NIST database, you can find these vulnerabilities that they have been reported, and they tell you like what these vulnerabilities are, all right, and what you can do with them. Okay, so for us to launch this, we do the same thing kind of in a way, and what we will do is we kind of use a real world penetration test scenario. And our attacker obviously here is going to be Linux, Kali Linux, and the target is going to be meta-exploitable. Okay, so the goal of the demonstration is to identify a vulnerability like Samba or the one we have did, and then we use the MSF console to launch the exploit and gate remote access to that machine. Okay, so this is obviously the first step that you would need to do, because if your machines are not under the same NAT network or NAT generally, you would not be able to ping or do any type of exploiting. So that is the first thing that you need to do, is to verify your connection. We don't need to do that step because obviously we just have launched an attack and it works successfully. The next thing that we do is we launch MSF console, okay, and we have did this here before. So let me go back here. I'm gonna do exits, then launch MSF console again, so I can search for the vulnerability. Okay, so let's go back here. We know the vulnerability, or kind of the name, the keyword of the vulnerability is Samba, right? So we need to search for that first, and that is the first thing that we do. So we go back here and we do search. Okay, there's like a lot of vulnerabilities, or you can say flaws or ways we can exploit this kind of weakness. But the one we're looking for is this one right here, exploiting user map underscore script. And that is the vulnerability, or you could say the version of the vulnerability that we want to kind of attack. Okay, so we will just use the exploit here. So we will do exploit, and we will do multi Samba, and then user map underscore script. We'll do yes here. So we don't need to set a port number here. We just need to set an IP address for the attack. So we have used the exploit now, and we want to set the IP address. So we're going to do set our host, and that was our host stands for. And then we enter our IP for the meta-exploitable machine that we have here. And you can do at this point 1. It already has a port number that is attached with it, which is here. Okay, so we have a session that is open and with the time. And then obviously, when we do who am I, we should have root access of meta-exploitable. Yeah, so we are root. So we confirm that we have full access control of the target machine. Okay, so now we kind of did like the feature of the vulnerability is remote access to the compromised machine, that what we have did now. And we did it based on obviously command shell session, as you can see. So the rest of that we have here, obviously in this malware, is very straightforward. We have kind of payload stealthing rootkits. Those are kind of like when we discuss the first portion of the chapter, is we have those kind of rootkits. They can be used from an attacking point of view, and they have multiple techniques. And those are used kind of like for immature or low-level programmers, or you could say low malicious actors that are not well in kind of implementing these malware attacks. And the idea that we have here when it comes to kind of the stealthing rootkits is basically going to be a program, and it's going to be a collection of these programs that are hidden, and they want to maintain kind of access. Okay, so their design is to hide attacker activity, and they do that by modifying the system monitoring mechanisms. So they mess with the monitoring mechanisms on the given target, such that nothing seems to be happening or noticeable, and they can access even full kernel access of the system. They can process files, registry entries, and do also mess with network connections. Okay, so it also provides the attacker with root privileges. Okay, so what they can do is not only they can hide malicious code, or kind of like obviously the vulnerabilities of that given malware, but they can modify, install programs. They can monitor the activity. They can control also network communication, and they can maintain these backdoor access for them. So the rootkit classification, they're very dangerous because they can be they can be hidden in different kind of functions, you can say, or different levels, where they can be persistent, they can be in memory based or user mode, they have access to kernel mode, it can be done virtual machine based or even external mode. Okay, and that's why the reason they are dangerous is because it makes them very difficult to detect and remove because they have different characteristics. Okay. So here is let me see if I can do present mode. Yeah. So here is kind of like a normal kernel system call flow that we do have. Okay. And basically we have a system call table here on the left side of the figure. And these are kind of like functions that we do have within the kernel. So for example, we have for entry, and this matches kind of what is being done. So kind of each given call or each given call function is matching with the intended of that given program. Okay, so this is a normal kernel memory layout. There's no issue that is here. Okay, so each entry point is legitimate and an actual kernel function that we do have. Okay, so when the program makes a system call, the kernel will look up the table and execute the correct function. Kind of similar to how we talked about databases. So this is obviously the structure that will ensure the normal operating system behavior. When it comes to these the rootkits that we do have, or you can say call hooking that we do have, that rootkit will modify that kernel because it can have access to that call table, right? And it can redirect the original functions to something that is different, to malicious functions like maybe read, execute, or fork. Okay, you don't really need to understand all these kind of kernel, you can say functions, but the idea is that they do have access and they can do multiple things. Okay, so the malicious functions will run first. They can process things, they can modify things, and manipulate the system behavior. And that is the technique that obviously these rootkits that have that characteristics, they can hook onto the system, and this is commonly used in kernel rootkits. So we'll talk about some countermeasures to wrap up the chapter, and obviously ideal solution to kind of prevent malware is we have four kind of elements. The first one is we have a policy, some sort of policy or incident response policy to fight against kind of malware. There's awareness to kind of the given employees, or you can say the insiders of the organization. There's a vulnerability mitigation. So how can we mitigate kind of these vulnerabilities? And there's threats where we can kind of do some maybe penetration testing to kind of make sure that our systems are audited in a way that they're good. Okay. If that prevention fails, we go to kind of the policy, and that policy is going to be kind of to support where they have some detection techniques, identification, and how to remove to get back to the original kind of slate or that beginning phase where the system is in a good solid state. So we have antivirus software, and most of you have that. I mean, if you're using Windows, you have Windows Defend System, these different antivirus. And there's kind of different generations of these antivirus softwares. The first one that we have is the first generation, and that is going to just detect malware signatures. Okay, so given malware patterns, we'll be able to detect of that. So it can only detect previous identified malware, because the way they feed these kind of first generation is that they would find vulnerabilities in previous malwares that were reported maybe, or they are public and available, maybe reported by researchers, and those would be used kind of in a database kind of for the antivirus engine to run. So when attackers would exploit newer malware, the first generation antivirus will not be able to detect it, okay? Because it can only detect based on what has been fed at that point. The second generation, it can kind of use some rules to find some suspicious or known malware. Could be kind of like other external features, could be like malware size, the malware family, and many other things. It can do integrity checking of their system files. And then we have activity monitoring. This will just monitor your system to kind of give you and kind of give you some reports or logs. It could be errors to let you know that there's an issue that is going on. Okay. So it uses memory monitoring to observe those program actions. And you can see those antivirus engines, they can run in the background to kind of have an idea of what's going on. And then the fourth generation is kind of full featured. It combines all the previous techniques from the first to the third. So it includes scanning, behavioral monitoring, and access control mechanisms as well. We have host-based behavior blocking software, and this will integrate with the operating system and monitors the program in real life. Okay, so this is kind of a mitigation, you can say, or a countermeasure, and it would also detect malicious kind of certain actions in the systems, and it can block them right away before it spreads to other systems. Okay, so that provides some advantage over the antivirus methods, such as signature detection or the one that is rule-based. So the idea is that these come internally with the system, kind of similar like to built-in GPUs, or you can say in-mode GPUs that come internally with some devices. This is kind of similar to the same. Okay. Some limitations obviously that do exist with that is that the malware can execute before its behavior can be analyzed. Like you can say the response of that kind of antivirus software or the host-based behavior is a little bit delayed or late. Okay, so the damage can occur before it is detected and blocked. And we have some, you can say, parameter approaches. So we have antivirus engines, obviously, that is integrated into multiple kind of given locations like email gateways, web proxies. We have firewalls and IDS systems. So we deploy these everywhere as well, not just in a given kind of or given OS. Okay, they can inspect network traffic. They can kind of to see if there's any entering or leaving organization. We use firewalls for that. We can use IDS system, intrusion prevention mechanisms that can block that specific traffic. And then we can help try to detect malware before it reaches the system. Okay, so this is the way we kind of have that multi-layer system hierarchy of system that is working. Okay, and then we have two types of monitoring software. We have ingress, and that is placed at the boundary. Okay, so the external, you could say externally, that is not internally within the organization, and it manages the external side within the gateway traffic, and before it reaches the internal side. Okay, that is also set by the admins. And then maybe we can use something that is also internally. Okay, and that is egress. So that is included inside the lines internally, and that can be used also for those insiders that we want to also kind of maybe protect from having vulnerabilities if they're maybe uneducated, or maybe we set some permissions for them, and that is a way to do that. Okay, so ingress can detect traffic or invalid IP addresses. That is what they do, and the one that is internally, they can kind of detect malware activities, and they can find any communication that is happening. So that is chapter 6. We kind of spent about, say 2.5 lectures on it. Had a lot of kind of hands-on. So we talked about malicious software types. So like viruses, Trojans, keyloggings, worms, and much more. We talked about propagation as a virus itself, so that is infected content viruses. We know how to kind of vulnerability exploit and how to search before that. And we didn't talk a lot about social engineering, but obviously that is one of the steps that can deploy malware, whether it's spam, email, or Trojans. And then the payload is what is the system corruption. Okay, that is what is going to cause that that malicious code to kind of run. And it can do many things. We said system corruption is one of them. They can delete files and much more. Similar to denial of service, which is our next chapter, we have kind of bots or zombies, you can say, that can kind of make the attacking way kind of difficult, and difficult in terms of kind of defending against it, but it will be more kind of like, you can say, an advantage for the attackers to use something like bots or zombies. And information theft like keyloggers, phishing, and spyware. And stealthing is the mechanism that we kind of talked about that would keep malware hidden in a given systems, and then we wrapped with some countermeasures. Any questions on chapter 6 before we move to chapter 7? Okay, that is good. So this is a very relatively very short chapter, but we have some demonstration with it that can kind of give you some ideas of how denial of service attack will be done, kind of on a smaller scale, but it still demonstrates the idea of denial of service. Okay, so obviously this definition is that obviously it's a type of attack, security attack, and it deals obviously very kind of objectively with networking specifically, and it's going to be that action that is going to be that prevents or kind of makes networks be kind of unused or given systems or kind of being down, so that we exhaust them with different resources or different kind of pings. There's different ways to deploy the attack based on pings, maybe based on the TCP three-way handshake, and that can rise up the CPU usage, memory, and bandwidth, and even disk space. Okay, so this is an active attack that we have, which is the denial of service. So it's a form of attack basically on availability of some service. So we know that there's some service that is running, and the resources that are running on that specific service can be attacked. And we have some categories of resources, whether it's kind of system resources, or we want to overwhelm the network to crash it so that it cannot handle any kind of software. Okay, it could be a network bandwidth such that the network capacity, the given links, the backbone links of the internet that is connecting to the ISP, is connecting to the data servers or proxy servers are going to be down, right? Because we know the idea of these backbone cables is that it can only handle a given kind of MTU, maximum transmission unit of size of given packets. That's why we kind of fragment them and then reassemble them when we're sending large data, like for streaming or such things. This kind of feature is not included in IP version 6 because IP version 6 removes this fragmentation and reassembly of packets and makes it a host-based feature. Okay, so that is one feature of IP version 6. So for most organizations, this is their connection to the ISP. And then we have application requests. And this is kind of like any kind of application that is pingable, and then we receive an echo reply from it. Okay, so we can also attack those such that it will be down, similar to maybe like when we had an AOS, maybe kind of downage. We don't know the issue with it, but that specific server or that resources is down. So to talk a little bit about, we want to explain some topologies when it comes to networking to understand how the attack is being done. Let's do here. Okay, so we obviously the internet as a topology or kind of an example of the internet is that we have obviously different switches, different routers. We have different types of internets, whether it's personal area networks, wide area networks, wireless area networks, even local area networks, right? You can have ones that are small. We can have ones that are big. Here, And then obviously these have nodes, right? And the nodes can kind of fall under classification of devices. So it can be PCs, printers, iPhones, anything that is kind of related to kind of under the category of a node. Similarly to web servers. So we have here medium-sized company, then maybe a large company, and then we have ISPs. Maybe this could be kind of like AT&T. There could be another one that is here. And those are obviously, this is the concepts of internet, is that every kind of given system is reachable using the internet. And we have these redundant paths that are being taken to kind of reach our destination. So the first thing that we have is a classic denial of service attacks, because there's kind of different types of how to launch the denial of service attack. And this one is flooding ping command. So you want to overwhelm the attacker with the capacity of the network connection to the target organization. So we do a lot of pings, and such that that destination that we are pinging has to handle massive traffic. Obviously this will have higher capacity links on the path, but the packets are discarded as capacity will decrease. And this is the idea, is that once packets are left, they will be kind of discarded or reach at a destination. Okay, so the idea is to how to implement the attack is to increase the rate of the given attack, which we will demonstrate in a minute. Okay, so the network performance is going to be noticeably affected. Okay, does anyone know how we can kind of mitigate denial of service attacks or some countermeasures? Yeah, a what? A load balancer? Well, I mean, you want to block that type of attack, right? You don't want to use a load balancer to kind of, load balancers could be used for that, but load balancers are used for usability for our actual intended real users, right? To kind of hold a request, and then when there's a request that is internally loaded, we can send it back to that given client. You wanted to say something? To have a countermeasure against denial of service attack.
Would it be like hardening the other device?
A what?
Hardening?
Hardening the device? No, not quite. I mean, could be, but we have some specific countermeasures that we will cover. Anyone else? Yes. Yeah, that is really good. So access control lists, maybe the firewalls, we modify the rules on the firewalls. And we have obviously these intrusion detection systems that we just discussed in the last chapter. Okay, so let's kind of launch this attack to give you a demonstration of what's happening a little bit. So this kind of lab is to kind of, we want to monitor the network traffic. So the objective is to introduce packet kind of sniffing and network troubleshooting by using TCP dumps. And we aim to kind of analyze ICMP traffic. So we analyze pings. And because when we do a ping or trace route, we're using ICMP traffic as a protocol. Okay, so we're going to do it between two machines so that you can see what is happening on each side. Okay, so the target machine that we want to kind of attack is Metaexploitable. Okay, and then the tool that we will use is TCP dump, command line packet analyzer. Okay. And ICMP, obviously, you have know of it, and it's the internet message protocol that is used for like diagnostic tools like ping and trace routing. Okay, so what we'll do here is that we'll go to Metaexploitable and we'll try to kind of launch this analyzer, TCP dump ICMP. Okay, we need to use sudo to get into this analyzer, right? And then we need to get to this packet sniffing engine to kind of find out if there's any pings that are happening. And then ICMP will kind of tell, hey, we want the search engine to kind of analyze ICMP traffic or ping related, right? If we were to do a denial of service attack against HTTP, we would want to use HTTP or SSH, okay? So that is the first step we will do. So we'll go back to Metaexploitable here. And what we'll do is, so I'm Ceph admin. You want to check our IP address really quick. That is the same to type, .2.3, okay, because that's what we'll use for the attack. So we want to launch this kind of engine. So we will do sudo, and then we will do TCP dump, and then ICMP. And then we will enter our password and admin. Okay, so that is waiting for it to be pinged. So we can leave this to the side now. What we go and do is we go on Kali, right? I want to show you a basic capturing handshake first, and then we can move to the attack. So when we obviously one side is listening now, and that has been exploitable, and we want to attack from Kali Linux, right? And we want to show the echo request from one side and the echo reply from the other side. Obviously, it includes sequence of the given kind of pings that are being sent and the milliseconds in time, so the round time trip. Okay, so what we'll do here is we will go to Kali Linux, and then we will minimize this here a little bit, or just leave it as is, and we will do a regular ping 10 0.2.3. Okay, so you can see that this is a regular system that is working kind of together such that we are pinging and this, the machine is replying. Could be a server replying to a request, and that is fine. So the idea here, this is kind of a normal behavior. It would not affect kind of the CPU usage of the other machine, and it would not be able to do any kind of harm to the machine because this is normal. So the way we do and launch the attack is we increase the rate of sending these. Instead of sending maybe 1 packet per given second, we can send 20 or 30. So we increase that rate. Okay. So let me stop this here. So you realize when we stop it on, I'm going to do exit. And then once you stop it on here, it should also stop on here. So the next thing that we will do is obviously we will use ping -I, and this is where the tweak comes in. So the -I flag will reduce the interval between the packets. Okay. So standard ping is 1 second. So this is like 0.05 seconds. Okay. 20 packets per second. Okay. That is what we assign here. So the result, obviously, it will kind of do like a rapid kind of fire output that shows kind of a stream of communication that is happening on both ends. Okay. So we notice the timestamps there are hitting very one after the other. Okay. So this is kind of the baby step in ICMP flood. We have pings. So if we scale it up to maybe 1,000, the CPU would max out. Okay, so just replying by saying hello back. So we will go back to Kali Linux here. And instead we will do ping and then -I. And maybe we can do 0.5 here. And then set our IP address. So that you can see that we are pinging very quick here instead of kind of like the normal behavior here. And obviously those need to be replied. So we have an echo request and a reply that is going out. So yeah, so we can increase maybe the time more here. We can do it maybe instead of 5, we can do maybe 10. And that would be faster. So you do get the idea, right? So address source or maybe address spoofing is kind of like we know a type of, we can say, mechanism or kind of an attack in networking where the attacker can forge their IP address, kind of similar to forging their access points as well. We have rogue access points. Okay, so that makes the attacking systems very harder to identify because we are not using our specific IP address. Okay, we're using someone else maybe IP address. So the attacker will do the same thing, but they would generate those packets from a different kind of source IP address. And obviously this would have congestion, it would kind of result the router, it would have a low capacity, and it would require these network engineers or IT engineers to kind of query flow information from their routers. Okay, so it'll be like a kind of backscatter traffic. So we advertise routes to IPs to monitor the attack traffic. This is how it's kind of done when we talk about really source address spoofing. Is that, for example, if we have not Bob and Alice here, we have two different, maybe a client and a server, and the client is kind of sending a message as it's them, that would be fine. But if we have an attacker that is doing some impersonation or kind of forging their IP address, they would act as they were Alice. Okay. In a network, we cannot really see who Alice is, right? We can only see IPs. When we look at the diagrams of IP version 4 or 6, we can only look at the IPs as a source and destination. So the next thing that we have is SYN spoofing. Does anyone know what that is? When we talked about SYN, does it have an idea of where this comes from? Yeah, that's correct. That is the first packet. Okay, so that is another kind of attack that we can use as a denial of service. Okay, so we attack the ability of the server and to respond for future connections. And it results by overwhelming obviously the tables that is used to manage them, or kind of the handshake. So the legitimate users are going to be left denied because the network is congested. And since that we need some sort of acknowledgements for these SYN spoofings, it would kind of take time for those to be kind of acknowledged, and we cannot acknowledge them because we're going to talk about the handshake here in a little bit. As the attacker, he would want to acknowledge them. He would leave them kind of halted in a way where the session is remaining open. Okay, so hence an attack is on system resources. It can kind of specifically the network handling code and the operating system. So this is what we have. Obviously, the typical TCP three-way handshake is we have SYN, and this is sequence X that is being sent to the server. The server will obviously receive, and we'll use a different sequence and send an acknowledgement back to sequence X. Okay, and that would keep happening for kind of a sequence of 3 steps till the session starts. So that is what TCP uses, right? TLS also kind of uses a handshake that is similar. Transport layer, periodic service, or kind of security, that would use this as well. So the idea that we were doing here is that the attacker would send kind of SYN and to the server, and we have a spoof client. But what is happening is that the acknowledgement is not coming back. So SYN acknowledgement to a non-existent client is discarded, right? That would be discarded here, and there's going to be obviously resending of SYN acknowledgement after timeouts. That is the time to live that we use here. So we assume failed connection requests. That is what's happening here. So we basically send the first step, but we can have kind of a feature to not acknowledge those, and those can be left without acknowledgements. So let's kind of do this very quick in Kali Linux here with Metasploitable, right? So the concept is resource, you can say, to exhaustion attack. Okay, we use the three-way handshake, and this is how almost every connection would start. Obviously, if you're using TCP, if we're using UDP, it would be different. But there's also kind of an attack with denial of service using UDP, which we'll cover in our next lecture. Okay, so the mechanism here is that the attacker would send the synchronize or the SYN packets to the server. The server would respond with SYN acknowledgements, okay, that is set for memory. But us as an attacker, we would never send the final acknowledgement for the session to start or for the handshake to be completed. Okay, so the attacker is sending that here. The server replies normally, but kind of the visitor or maybe here is not kind of sending the acknowledgements back. So it's waiting for acknowledgements. Our actual users cannot actually connect. They cannot send the first handshake. So it fills up, the server would fill up with first or half open connections, and the legitimate users would be denied. So in network logs, when kind of network admins or kind of engineers would detect, they would kind of look for SYN receive. Those are the stop connections that would appear. Okay, so what we do here is we use obviously this given command we use HPing3 to fire millions of SYN kind of packets to the target web using port 80, okay, and without waiting for a response. We verify it here on obviously the other end, which is Metasploitable. And you can see that the terminal will show multiple connections that are stuck in this send_receive state. So the attack will be successful, and the target is kind of using the CPU or memory, kind of affecting the device with half open connections. Okay, so let us do that very quick. So if we go to first, what we want to do is we want to open the analyzer, the network analyzer here. So I'm going to stop this here, and we can do sudo netstats minus n, and then we would do grep, and we would look for these send receive. There's something that is wrong. Sudo stats minus n send score or HP. Maybe we have to launch that tab first. So let's switch and do this command first and then see what happens. So we go back to Kali Linux. And what we'll do here is we'll use this command that we have here, which is sudo and hping 3. If it turns blue, that means the command is valid. So minus s, and then we would do flood using port 80 with the IP that we have. Okay, so you can see that no replies will be shown as we're kind of like hping in flood mode. Okay, we're sending about 40 headers. There's no data bytes that is really happening, just basically headers, packet headers that are being sent. Let's see if we can go back here and analyze this. Yeah, you can see that we're kind of getting some packets with specific port numbers here, obviously when we have processes, right? For each given request that we do send. And we use kind of port numbers for that. So port numbers not only identify the service for us, but they can identify that specific request for us as well. Okay, so and we can see our IP address being sent, and those are kind of stuck. So we don't acknowledge them on this end. Okay, so one more thing that we had. Yep. So that was that is that. So we kind of have another variation of attacks that we'll cover on Thursday. We have kind of bots to also go. Where denial of service that uses bots, and we would wrap up the chapter. So that is it for today. If you don't have any questions for the ones on Zoom, you can go ahead and exit, and then we will take attendance very quick. Thank you, Andrew. Have a good one.